Hey, hi to everyone. MEM School of Engineering, Mechatronics, Mechanical Department, Subject Mechatronics, Unit number 3. So, myself, Saravan, Assistant Professor in Mechatronics Department. Okay, so today we are going to see about the Unit number 3, that is Programmable Peripheral Interface. So, last class we discussed about architecture of 8255. 8255 is a programmable peripheral devices which is used for generating the ports, port A, port B, port C, like that we discussed. Same. Then we discussed about different modes available in the 8255, like that we discussed. Okay, next interface is keyboard. Okay, if we want to connect the keyboard with the processor and our controller, okay, so we need to set the key. Okay, we need to read the key, so we need to use the input port. Okay, like that we are going to discuss in the keyboard interfacing of 8085 and 8051. So this is 8255 programmable peripheral device architecture and other concepts we discussed in the last class. So keyboard interfacing. So it is a method of entering program into the microprocessor through a keyboard, which consists of set of switches. Yeah, momentary contact switch is typically used in the keyboard, and the closure can easily be detected by a microprocessor using the simple circuit. Okay, so this is the concept. So generally key done by the switches. Okay, so if you are fixing the key in the particular manner, that is, if you fix the matrix manner, we can calculate, we can identify the which key is pressed, like that we can calculate using the switches. So this is the basic model of switches connected with the power supply. Okay, if a press means the power supply 5 volt will be given to the ground, so output is 0. If I open this switch means 5 volt will be given to the output. That means if switch is not present, so output will be 5. If I press the key means output will be 0. So okay, for this way, by use these functions, we can calculate the switch whether the key is pressed or not. Okay, like that we can calculate using the keyboard switching time period. Okay, this is the concept used in the microprocessor keyboard interfacing. The processor has to perform the following three major tasks to get a meaningful of data from the keyboard. So one is keyboard scanning, then debouncing, next is decoding. So consider a simple keyboard in which the keys are arranged in rows and columns as shown in figure. So the rows are connected to a port A, so lines of 8255. The columns are connected to port B, so lines of the same chip. The rows and columns are normally tied high. At the intersection of a row and column, a key is placed such that processing a key will short the row and column. Okay, this is the concept. So if you are using 7 keys means you need to connect 7 keys with the particular port. Okay, in yes, if you are connecting in the series manner, if you are using 20, if you are using 30 means you have to increase the n number of input output ports. So that is not available in the most of the systems. It will increase the cost of the system. So the keys are, the switches are connected in the matrix format. For example, in this diagram, we are connected the 16 switches in the matrix format, but we can access through these 16 switches through the 8 ports only. Okay, that is reduced in the off. Okay, so this is the concept. Okay, here they are using 8255 because of we are connecting with the system of 8085. Okay, 8255 they are having 3 ports, port A, port B and port C. Here we are connecting with the port A. So there is a row connected with the power supply plus 5 volt and column connected with the plus 5 volt power supply. Okay, when press the key, which key is pressed, that is if row 0 is pressed means, so these two lines are connected, so it is connected means it be grounded. Okay, the power supply will be grounded. This is the concept. Okay, So using this table, we can identify the which key is pressed. Like that, we can calculate. So keyboard scanning is the process of having microprocessor look at the keyboard matrix, so at a regular interval to see if a key has been pressed. Once the process determines that a key has been pressed, the key scanning software filter out the bounds and determines which of the key was pressed. Each key is assigned a unique identifier called a scan node. This scan code is used by your application to determine what action is to be taken based on the key pressed. The scan code tells your application which key was pressed. So during initialization, all rows and rows forced low. When no key is pressed, all columns are high. So if any key is closer, will cause one of the column to go to low. To see if a key has pressed, the microprocessor only needs to see if any of the input lines are low. Okay, once the microprocessor has detected the key has been pressed, it need to find out which key it was. So this process is quite simple. The microprocessor outputs a low one, only one of the row. If it is find the zero on the input port, the microprocessor know that the key closer occurs on the selected low. So this is the concept of we are finding the key, which key is pressed. This scan code of key pressed is typically placed in the buffer until the application. Okay, is he ready to process a keystroke? The microprocessor take the sample of key pressing. So in the particular time period from 20 millisecond to 100 milliseconds called the debounce period. Because most of the, so if any of the switches is pressed for the long time means we need to debounce the data. So every time the microprocessor will check the whether any key is pressed or not, like that. They are scanned. That is between 20 millisecond to 100 millisecond. So here they are using buffer is generally implemented as a circular queue. So when a key is pressed, the scan code is placed at the next empty location in the queue. When your application obtains a scan code from the keyboard module, the scan code is extracted from the old location in the queue. So if the queue is full, any other further keystrokes are lost. So this is the concept of auto repeat of key release and key press. So this is the concept flowchart for the initialization, key up, debounce, wait to start and repeat, wait for next repeat. These are the process used in the keyboard processing. Okay, this is keyboard interfacing. So let's see interfacing of keyboard with the 8051. Interfacing with the 8051. Interfacing with the 8051. Okay, so here difference is they are using 8085 with the 8255. Here directly they are connecting the keyboard. So keyboard interface they are connecting with the direct with 8051. So the keyboards are organized in the matrix of row and column. The CPU processes both the rows and column through the ports. So with the two 8-bit ports, the 8 cross 8 matrix of keys can be connected to the controller. So when a key is pressed, a row and column make a contact. So otherwise there is no connection. In microcontroller, a program stored in the EEPROM scan the keys continuously. So in the following figure, forecast for matrix connected to two ports. Rows are connected to output port and the columns are connected to the input port. So this is a direct port 0. In already we know that 8051 we have ports 0, 1, 2, 3. Here they are connecting the ports with the um, port 0. Okay, so that means they are connecting the port 0 and port 1 they are using for the column line. Okay, when press 3, so the D0 and D3 will be enabled. Okay, when press 3, D0 and D3 will be enabled. Using this, we can identify the value of 3. So when 7 is present, D1 and D3. When D2 present means B and B present means D2, D3. When D3 present means here F. So like this, they are using the identify the keys of keyboard, which key is pressed. So scanning and identify key in the 8051. It is a function of microcontroller to scan the keyboard continuously to detect the identify key pressed. To detect pressed key, microcontroller grounds all row by providing 0 to output latch. Then it is read the column. If the data read from columns D0, D3 and D0 is equal to 111, no key is pressed and the process continues till key is processed. So key is press detected. If one of the column bits has row, it means key press has occurred. If D3 or D0 is equal to 1101, this means the key in the D1 has been pressed. Okay, that is this represent D3, D2, D1 and D0. That is D1 is 0. So after detecting the key press, microcontroller will go through the process of identification key. So in microprocessor, it is having the lookup table. For each key, it is having the different codes for the execution. Okay, they are putting a 1101 means D1 is enabled. So this key is this key value will be loaded into the lookup table that was represented in the output. So that is a concept of scanning and identify key. So start with the top row. The microcontroller grounds it by providing a load to a row D0 only. If reads a column, if data read as far is all once. So no key in the row is activated and the process is moved to the next row. It grounds the next row, reads the column and checks for any 0. So this process continues until the row is identified. After identification of row in which key has been pressed, find out column the press belongs to, which row, which column is defined. This is the concept of keyboard identification. So this is a key chat. Initialization key up. So key press. So clear the key down like timer. Then debounce. That is key will pressed and debounce time as expired. Find which key was pressed. Place key code is buffer. Place key code in buffer. That is increment key down timer. Then wait to start auto repeat. Okay, that means if the same key is uh, repeatedly they are asked. So key will pressed and delay to auto repeat elapsed. Find which key was pressed. Place key code is in buffer. Increment key downtime. Wait for the next repeat. Okay, then it will go to the debounce. So again you will check the debounce okay. Then you will go done the process. So these all the key pressing process done in the microsecond concept. Okay, microsecond concept. So mostly keyboards are used for input, we are giving the input. If in 8085 basic programming, we need to type the opcode in the program, opcode in the processor. So we need to use keyboard for the input operations. Okay. So this is the concept of interfacing keyboard with 8085 and 8051. Okay. So remaining next class, we will see the LED interfacing with 8085 and 8051. Okay. Thank you all.